Algebra 2, this is section 5.10, and we're going to talk today about something called the quadratic formula. So the quadratic formula is another way of solving quadratic equations that are in standard form. So far, how have we solved quadratic equations? Well, if we saw an equation that was in vertex form, the quickest way to solve this would be to take the square root of both sides. So we're going to find that if we take the square root of both sides, we're going to end up with x plus 1 equals, plus or minus, that's the intelligence that you're bringing to this problem, plus or minus the square root of 7. It has two numbers that are answers. So your answers are x equal negative 1 plus or minus the square root of 7. Okay. Now, what you're doing here is solving by taking the square root of both sides. When will this work? This works when, one side is a perfect square. So when you can see the side that has the variable expression, when that side is a perfect square, you can take the square root of both sides. When does this not work? Okay, when you do not have a perfect square. So when you do not have a variable expression that is a perfect square. So for example, if you had x squared plus 2x equals 7, people will try to do it, but you cannot. I mean, mathematically that's correct, but it doesn't get you to any solution. The left side is not a perfect square, so that will not simplify. The other method we talked about solving was solve by factoring. So not everyone will factor, but if this factors, you have a method. I'm looking for numbers that multiply to negative 30 and add to negative 1. The factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. The only way to combine those numbers and get a negative 1 is with a 5 and a negative 6. So you rewrite this as 10x squared plus 5x minus 6x minus 3 equals 0. That allows you to factor by grouping. You can take a 5x out of the first two terms. That leaves you with 2x plus 1. Copy down the minus sign. The 6 and the 3 have a 3 in common. Technically, it's a negative 3, but you've already taken care of that. What do you multiply negative 3 by to get negative 6x? That's 2x. What do you multiply negative 3 by to get negative 3? That's positive 1. So this is 5x minus 3, 2x plus 1. Set each factor equal to 0, and you'll get x is equal to 3/5 or negative 1/2. This will work when you, and it sounds basic, when you can factor, okay? What if this had been numbers that multiply to 30 and you add to, 28, okay? Well, none of these numbers do that, so it will not factor. So when would this method not work? When you cannot factor. Okay? So both of these methods so far had limitations. Taking the square root only works when you've got something that's a perfect square. Solve by factoring only works when you can factor the expression. The next one we did was solve by completing the square. So for example here, the method here was to say x squared minus 12x equals 3. And what you want to do is to make this a perfect square, half of 12 is 6. So if I add 6 squared to both sides of this equation, then I've created a perfect square. So on the left, I have x minus 6 squared, because that's x squared minus 12x plus 36, is equal to 36 plus 3 is 39. Now you go back to the first method of taking the square root of both sides. X minus 6 equal plus or minus the square root of 39. Therefore, x is equal to 6 plus or minus the square root of 39. Okay. This method has no limitations, okay? So it will always work. When will it not work? No, it will always work, but it's not people's favorite method. Okay, for some reason, it is just, it's not a sophomore's favorite method. This one was sort of a straightforward problem, but a lot of times you get complex numbers, you get fractions. The arithmetic and the algebra can get a little bit bogged down in doing this method, but it will work every time. We have another method that will work every time. So if you're solving ax squared plus bx plus c equals 0, this is a quadratic equation set equal to 0. The solution is given by this formula called the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Okay, so it looks a little complicated, but if you will work with it and write this formula down every time you use it, you won't be spending the night before the test memorizing the formula. It will become part of your muscle memory if you've done this. So when I look at this equation, you've got x equal negative b plus or minus the square root of b squared minus 4ac over 2a. The left side of this equation, that's x. The right side of the equation here, okay? The left side, that's the algebra, okay? The variable is x. I have already solved for x. I've given you a solution for x. So the algebra part is pretty simple. On the right side, this is all arithmetic, okay? These are numbers, these are plus and minus, these are square roots, these are squaring, this is dividing, okay? So if you think about this, if you've got to square a number, that's one mathematical operation. Subtract, that's another mathematical operation. 4 times a times c, that's 2 multiplications. So I'm up to 4 mathematical operations. Square root, that's 5, okay? And then you've got plus or minus b, that's going to be 7, and then you're dividing that by 2a, which is a multiplication. So it's about 9 or 10 different arithmetic pieces that have to work together to get this right, okay? So you want to take your time in doing this. Now what some people will find is, that if you do part of it, if you do this part first, find b squared minus 4ac first, and that's a number. Then I can just substitute that number into this formula. Some people find that to be a more straightforward way to breaking the problem up into multiple pieces. So I can do some of these both ways. You can make your choice about how to do it. So let's look at this one. To solve a quadratic equation, the equation must be set equal to 0. X squared minus 5x minus 7 equals 0. Because the equation that I'm solving is ax squared plus bx plus c equals 0. Now the quadratic formula, I would write this down as many times as I can, because there are people who get on a test and they write this down incorrectly, which means the answer is wrong. So make sure you get the formula right. Negative b plus or minus the square root of 2, plus or minus the square root of b squared minus 4ac, everything over 2a. Now we can substitute in the values. X is equal to, now what some people would do is they'll write over here, a is equal to 1, b is negative 5, c is negative 7. So x is equal to negative b, that's going to be 5, plus or minus the square root of b squared minus 4a c, all of that over 2a. So this is x equal 5 plus or minus, this is 25 plus 28 over 2. So this is x equal 5 plus or minus the square root of 53 over 2. This doesn't simplify. 53 is a prime number. Okay, so you can write your answer like this. X is equal to 5 plus or minus the square root of 53 over 2. You could write it as x equal 5 halves plus or minus the square root of 53 over 2. Either way. Now if you look at this, the number of solutions, I got two numbers out of that. They are real numbers, yes, and they are not complex numbers. I got two real solutions out of this problem. Now, another way that I said people will often approach this problem is they will first start with, say, b squared minus 4ac is equal to negative 5 squared minus 4 times 1 times minus 7. That's equal to 25 plus 28, which is 53. So then what people would do is say, okay, I can write x is equal to negative b plus or minus the square root of 53 over 2a. It just breaks, it's the same amount of work, but it breaks it into two steps. So this is x equal negative b is going to be 5 plus or minus the square root of 53 over 2. Okay. Some people just like this, breaking it mentally into two steps rather than having this whole big step here where you've got to do all your work under the radical and keep carrying the other information. Basically, it's work under the radical first and then go substitute into the quadratic formula. So whichever way you prefer. Let's look in this case. I need everything to be equal to 0. So if I subtract that 2x, I get 4x squared minus 12x plus 9 equals 0. So in this problem, a is equal to 4. B is negative 12. C is 9. So the quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac over 2a. So let's figure out, what is b squared minus 4ac? In this problem, that's negative 12 squared minus 4 times 4 times 9. That's 144. And then 9 times 16. 9 times 6 is 54, so 9 plus 5, that's 144. This is 0, okay? So b squared minus 4ac is 0, so the quadratic formula becomes x equals negative b, that's 12, plus or minus the square root of 0 over 2 times 4. So this is x equals, the 0 just goes away. This is 12 over 8, which is what? 3 halves. So that's my answer here, x equal 3 halves. So here I have one solution, and it's a real number. Solve the following equation using the quadratic formula. I'm already set equal to 0. A is 1, B is negative 6, C is 10. So the quadratic formula, x is equal to negative b plus or minus the square root b squared minus 4ac over 2a. So b squared minus 4ac is negative 6 squared minus 4 times 1 times 10. This is 36 minus 40, which is negative 4. So now, when I go substitute in the quadratic formula, x is equal to negative b, that's 6, plus or minus the square root of b squared minus 4ac is negative 4 over 2a. So this is x equals 6, plus or minus. The square root of negative 4 is 2i over 2. Now I want to simplify. This is not in simplest form because all of those are even numbers. This is x equal 6 over 2 plus or minus 2i over 2. This is x equal 3 plus or minus I. So in this problem, I got two solutions. X equals 3 plus I. X equals 3 minus I. Two complex solutions. So what I'm seeing here is, first problem, What did I get? I got 2 real solutions. Second problem, I only got 1 real solution. Third problem, I got 2 complex solutions. We're going to spend the next lesson delving into how and why that happens. I'm just trying to get in the practice of recognizing the solutions that you see. This quadratic formula only works for a quadratic equation set equal to 0. So setting this equal to 0 is 3x squared plus 14x plus 9 equals 0. In this problem, a is equal to 3, b is 14, c is 9. Quadratic formula, x is equal to negative b plus or minus the square root b squared minus 4ac, all of that, over 2a. b squared minus 4ac is equal to 14 squared minus 4 times 3 times 9. That is 196 minus, what is 9 times 12? 108. So 196 minus 108. That's an 8. So 88. So this problem becomes x equal negative b plus or minus the square root of 88 over 2 times 3. So this is x equal negative 14 plus or minus the square root of 88 over 6. Now we've spent time simplifying these radical expressions. 88. I know that that is divisible by 2. 44. That's divisible by 2, which is 22. That's divisible by 2, which is 11. So the perfect square here is 4. So this is 4 times 22. So x is equal to negative 14 plus or minus the square root of 4 times 22 over 6. So this is x equal negative 14 over 6 plus or minus 2 root 22 over 6. So 14 over 6, that's negative 7/3, plus or minus that 2 6 is 1/3, so square root of 22 over 3. So here I see 2. The solution is x equal negative 7/3 plus or minus the square root of 22 over 3. 2 real solutions. And that should take you up into homework for this section. Okay, and you can solve the solutions there.